Okay, this is a lesson for day 8 for Algebra 2, dividing polynomials. The objective: students will divide polynomials using long division, including skipping degrees. Up to now, you've been working where you take like a binomial or trinomial and multiply it by another binomial or another trinomial. So let's just say that you had two binomials being multiplied. This was an Algebra 1 concept. You multiplied it out and you would get the answer x squared plus 3x plus 2. And that would be your answer. Today what you're going to do is you're going to go backwards. You're going to start with x squared plus 3x plus 2. And you're going to divide that by one of the two factors, which is x plus 2. Okay, and you're going to work backwards. Recall in long division, whenever you did long division, 56 divided by 8, you would put the first number inside of the division sign, and then the second number on the outside. 56 divided by 8 is 7. You multiply 7 times 8. 7 times 8 is 56. You bring that down here. You line them up. You subtract, your remainder is 0. Therefore, your answer is 0. Your answer is 7. Now, if you were doing another kind of problem, let's say it was 42 divided by 5, you would notice it doesn't go in perfectly, but you could go 8 times 5 is 40. You subtract, you get a remainder of 2. We can't do anything else with it, so our answer would be 8. Then you would write it in the numerator, you'd write the remainder of 2 over 5. And this would be your answer. So this is these are things you should be good at. If you're not good at this, then you should get some time to practice this. Talk to me, or just practice on your own. I'll be glad to help you out. So polynomial long division works as follows. We have x squared plus 3x minus 12 divided by x minus 3. The first thing you want to do is you want to set up a long division problem, and you put the first trinomial or the first expression inside. And when you do it, you want to make sure that it's in descending order. So our largest exponent here is 2. That means the next one should be 1. Now there's nothing there, but we know we could assume that's a 1 there. And minus the constant of 12. Then you take the second binomial and you put it on the outside. Now that we know it's in descending order, we focus on the leading term, which is our x here. We have an x here, and we start with a leading term in the first expression, which is x squared. We want to ask ourselves, x times what is going to be equal to x squared? So again, x times what is going to be equal to x squared? Now I know that x times x is going to be equal to x squared, so I'm going to put an x up here. And we multiply it out. We go x times x is going to be equal to x squared. And then x times negative 3 is going to be equal to negative 3x. Next thing you do is put parentheses around that, subtract it. X squared minus x squared is going to be equal to 0. Positive 3x to the first minus negative 3x to the first is actually going to be positive 6x. So you have to be careful with your integers when you add and subtract them. Then you bring down the next term, which is the negative 12. We ask ourselves, how many times does x go into positive 6? We know that it goes in positive 6 times. Or another way you could ask is, x times what is equal to positive 6x? We multiply by positive 6. Now we go multiply this out. Positive 6 times x is going to be equal to 6x. Positive 6 times negative 3 is negative 18. Put parentheses around it. Subtract 6x minus 6x is 0. Negative 12 minus negative 18 is positive 6. Now that's our remainder. I don't have any more numbers here to bring down, so we can't continue on. So now we write our answer. We go x plus 6 is our answer, plus our remainder, which is going to be 6 again, but we want to make sure we put 6 over our divisor, which is x minus 3. That's how you would do this first type of example. Continuing on to the next example. We're going to keep moving forward here to checking for factors. Now, in your homework, you're going to have to know how to check for factors. Remember, factoring is like breaking something apart. In Algebra 1, you should recall that, let's say we wanted to factor this term or this trinomial here, this expression. We would know that you would make two binomials, and when you would factor, you get x plus 2 and x plus 4 as your two factors. Now, we know these are two factors, and this is an easy example, but you know that x plus 4 is a factor. So the question is it a factor? You would say, yes, it is a factor. Okay? We know that. However, our question isn't, or the point of this part of the lesson isn't because you know how to factor it quickly. The point of it is using long division to know what the factor, or to know if a factor would work. Okay? Because not all the time will the factors work. So what we do is you start with a long division problem, x squared plus 6x plus 8 in descending order divided by x plus 4. Now if I do this correctly, I should get x plus 2 on top right here. Okay, so let's just figure it out. Starting with the leading term. What do I multiply x with to get x squared? Multiply by x. So x times x is x squared. X times 4 is positive 4x. Put parentheses around, subtract. X squared minus x squared is 0. 6x minus 4x is positive 2x. Bring down to positive 8. Now we ask ourselves, what do I multiply x with to get positive 2x? I know that I need to multiply it by positive 2. Okay? 2 times x is 2x. 2 times 4 is positive 8. Subtract, you get 0. Now, remember earlier, this was one of my factors. So the point of this this part of the lesson is not that you know how to divide again, but that is it a factor is the question. So we know it's a factor if down here our remainder is 0. Since our remainder is 0, we know, yes, this is a factor. Okay? And this definitely agrees with what we had earlier in this. Again, this was an easier example so that you understand the process of it. When you do your homework or another test question, you'll see more difficult examples. Lastly, let's go to skipping degrees. Okay? Now, at the beginning, remember when I said you set up your problem, you want to have a descending order of exponents. So you have, in this example, you have a division problem, and your first term is x squared. That's your largest term. And then you have plus 3. Now remember I said it was supposed to have descending exponents, right? Descending values. So this is x to the second. The next one should be x to the first, but there is no x to the first here. And so since there's no x to the first, we need to erase that plus 3 and put placeholder, which would be plus 0x to the first. Even though I'm adding a 0x to the first, I'm not really adding or subtracting any value from my expression. Then I go to the next one, which is x to the 0 power, or just really a constant, which we know is going to be plus 3. We do that because if we don't do that, then your problem will turn out wrong because it'll turn out all messy and incorrect. So make sure you put that in descending order. Then you put your divisor, x minus 1, and continue like before. We have an x here. What do I multiply this x to get x squared? We know that I multiply that with x. X times x is x squared. X times negative 1 is going to be negative 1x. Parentheses, subtraction sign, and we start. X squared minus x squared is going to be 0. 0x squared minus a negative 1x is going to be positive 1x, or just x. Bring down the positive 3. What do I multiply x with to get positive 1x? I multiply by positive 1. So 1 times x is 1x. 1 times negative 1 is negative 1. Parentheses, subtraction sign, we get 0. Positive 3 minus negative 1 is positive 4. We have a remainder in this example, so now we have to write our answer with a remainder. So we have x plus 1 plus the remainder of 4 all over our divisor, which is x minus 1. And that's how you do a problem without skipping degrees. Okay. This concludes our lesson on dividing polynomials.